Hey everyone, it's Jordan Manis, week 4 interactive lab. We're going to make some elephant toothpaste with some household products. So we have our hydrogen peroxide 3%, most highest I could find percentage wise. We have our yeast. We're going to go with some blue food coloring, and we have our dish soap. So I actually did this just a couple minutes ago and had everything laid out just the way I do now, but for some reason couldn't follow my own instructions and I forgot to use the soap. So interestingly enough, I'll be able to do a little bit of a comparison between the two experiments and talk a little bit more about the difference the soap is going to make. So happy accident, but so let's see what we get by following the instructions this time. So let's get our our 3% hydrogen peroxide. We're going to do half a cup. I also learned last time not to use as much water. So I had a lot of water mixed in with my yeast last time. It didn't really give us a good mixture. So we're going to add our couple drops of blue food coloring. And I almost forgot it again, but we're not going to forget our soap this time. All right, so now we're going to give this a little bit of a mix. All right, and we're going to get our hot water. Got a new Insta Hot, it's a great feature. I think I've used it more for this class in Chem 125 than I have any other time. All right, stir up our yeast and water. All right, let's get our yeast packet out of the way. We're gonna center our container into our cooking tray here so we don't make a giant mess. And all right, let's see what we get. So immediately I can see a difference from the first experiment that I did without the dish soap to now with the dish soap. I'll take a screenshot of the last video that I made without the soap to show the comparison. But like I said, right away I can tell the difference. And the difference being is the soap, you can just see it right away, gives the more surface tension to the liquid, and it keeps it, bound together more than it did without the soap. It was a lot more watery and runny and not as viscous, I guess, would be a good way to describe it, as this is right here. So this is pretty, sticks to my finger almost like a cool, like a whipped cream or something along those lines. So here's our elephant toothpaste, and we'll be back with our analysis once we clean up. Okay, so we're all cleaned up downstairs, and now we're going to get ready to talk about what we saw. So hydrogen peroxide, H2O2, it breaks down into oxygen and water. So normally this reaction happens pretty slowly, and in order for us to see it as quickly as we did, we had to add a catalyst, and in our case we used the yeast, which in turn catalysts are used to speed up reaction times. So when the hydrogen peroxide comes into contact with the yeast, it starts to break down into the water and oxygen in a more rapid manner than it normally would. And oxygen is a gas in this case, and therefore wants to escape from the liquid. In the second experiment that I actually recorded for this video, I did use the dish soap, and the dish soap traps those bubbles from those gas bubbles from escaping like they would if we didn't have it. It was just water. So this is what actually made the difference in the two experiments. So the first experiment, without the soap, I got a little bit of a foam, but like I said before, it was more runny, more liquid than the second time, and that's because there was no soap. There's to capture the gases trying to escape from the liquid, and that in turn creates a foam, which we did see in the second experiment when we used the soap. So this reaction continues until all of the as long as there's hydrogen peroxide and yeast left. And the reaction did take quite some time to complete, and more of the foam was coming out of the container until it was all expended and the reaction was complete, and then it stopped. And again, we didn't see any new foam at that point. So that's what we saw today, and it was nice to have accidentally done it both ways to see the difference in how the soap captures the gases and changes it from being a liquid into a foam. That was pretty quite interesting. So that's all I have for this week, and I will talk to you next week. Take care.